I'm Timothy Precella, and I'm here with my brother Anthony Precella. And now that it's the third week of the semester, I want to make sure y'all are aware of some stuff that we talked about at the beginning of the semester, but that was just hitting you in the face probably. So it's time to remind you. If you go to the Canvas course homepage, click My Lab and Mastering, open My Lab and Mastering.
This is actually a better way to go than just clicking on the sidebar on assignments, because they don't show everything on that sidebar.
So if you want to see everything arranged, all the assignments, quizzes, and tests arranged in order by the date on which they're due, click Assignments, and you can go through and you see everything that you're going to be doing. Gosh, it seems like so much, but
it's two courses.
I know, you're right. Okay, so, but anyway, so that's my preferred method of accessing the course homework. Now, let's suppose that you've taken a test. Remember, you can take each test twice. So let's suppose you take a test.
Unless you take it after the due date.
Yeah.
You don't take it, if you don't take it before the due date, then Pearson, when they record a 0 for the first, that'll count as your first attempt. Okay?
So go to Gradebook and you find wherever the test is or something.
You haven't taken a test, so it's not going to show one in your Gradebook.
That's where you click Review. That is the only time you should use that review option, okay?
When you're looking at your test.
When you're looking for the test, oh, what did I miss? I'll study a little more and then retake it, okay? But that's the only time that you should use that review button.
Otherwise, you can just access the homework
through assignments.
Okay.
There's another thing I wanted to point out to you. Suppose you're on the 14-day free pass, and then it's time for you to you've bought the code or you're going to pay online, but you have to pay for access. Your 14 days has expired. You can go open My Lab and Mastering. You can click there, and it's not going to let you do anything. It may pull you up automatically to My Courses. Do you see this? And when you get to My Courses, now we have a whole lot of courses, but I'm assuming you only have one, okay? But there'll be a little statement here. I bet you most of y'all, I think the default is these little blocks like Canvas, but they'll have a thing here that says, oh, your access has expired. Do you want to pay now? So just find your course. It'd probably be the only math course that's listed there, and you click that little emblem there when you're ready to pay. Is that clear?
Either with a credit card, debit card directly from Pearson, or typing in the access code
that you bought at the bookstore.
If you pay directly or buy it directly from Pearson, it's a few dollars cheaper, and they don't actually give you a code to type in. You only get a little code if you buy the access card from the bookstore.
Okay, but now let's go back to our assignment. Is that all we need to say?
I think so.
Okay, so now we're going to solve quadratic equations. And the last time, I can skip over the prerequisites and stuff. You can't do that. You got to get a 70 on every homework assignment, on the homework assignment to move on.
And Tim, this is what you were talking about earlier, those lecture videos there. Even if you don't need to watch them, you still got to click them. If you find yourself making real close to 100, maybe a 98.5 but not 100, and you think, I've gotten every problem right, well, wait, no. It makes you click on them before you can even click the homework, right? Okay, that's a change for the better. So this is a 15-problem assignment. The third problem in the homework, don't panic when you see what it says when you click on it. It's one that I never really liked, and I think on Thursday, Tim decided, well, heck, since you don't like it, he doesn't really like it either, just remove it. So the third question has been removed by the instructor. Continue on to the next question. Everyone's third question is already done for you. Okay? So I guess The first two are the same thing we were doing at the end of the previous assignment. Let me start writing a little something, or do you want to do this, Tim? We said the last time that a quadratic equation has to have an x squared in it. It's in the form ax squared plus bx plus c equals 0. And this is where a, b, c are the numbers. We're going to see three methods for solving quadratic equations in this lesson. The first one we've already done, the factoring method. A word of note, or a little something I prefer. When I'm solving a quadratic equation, it doesn't matter which method I'm using. I prefer for a to be positive. I prefer for this first number, a, to be positive. Now that's not any sort of rule. It's just my little guide. I think it makes it easier to solve, regardless of the method that we're doing. And we're going to see three methods to solve these quadratic equations. Remember, quadratic means x squared. Do you remember if you have an equation that doesn't have a square in it, it just has an x? Do you remember what it's called? It starts with an L.
Starts with an L because the graph, the picture of it would look like this.
Linear equation, okay. That's right. So we have quadratic equations, we have linear equations. Three methods for solving quadratic equations. The three that we're going to see. The first one we've already done, the factoring method. And that's what the first two problems are.
That looks like a U.
That looks like a U. Wow, Tim. Factoring, okay. Okay, what was I going to say next?
The second method is the square root method.
The square root method, okay. But that's good. I need to pay more attention to my writing. And the third method we'll see today is called the quadratic formula.
Now, when solving quadratic equations, there's another method that's generally accepted called completing the square, but I think that works better when we get to circles. And so we're going to look at how do you complete the square when we get during our discussion on circles. But when solving a quadratic equation, there's really no time that that completing the square would be the quickest method, okay? But we will see completing the square when we're working with circles.
What's wrong? Remember, your voice is coming and going.
That's the placement of this thing.
Oh, okay.
Is that better?
Maybe.
Is that better? Can y'all hear me? Over there in the, I want to call y'all the peanut gallery, okay? Even though you're not elevated. I think we need to do something. We need to tell them we want that room maybe 2 feet higher. What do y'all think? Raise the floor? Yeah, I don't know.
I would think they'd never do that, but I thought they'd never make a room with a wall in it for us when I asked, jokingly, years ago. Now, let's go ahead and do the first two problems on the assignment, just to review that factoring stuff that we were doing.
Weekend,
yes. So this is problem one. It says solve, and it doesn't say by factoring. I sort of wish they had. I think number two, it does say solve by factoring. Yeah, okay, but I can't control the instructions, but this is solve by factoring. S squared minus 9s. Oh, this is gonna. I've got to be careful with my writing, don't I? Because an S looks like a 5. There's no 95 on this problem. Okay, it's a S squared minus 9s minus 10 equals 0. Okay. Now, the last time we said in order to solve an equation by factoring, you've got to have it in the standard form. I didn't mention that I prefer that first number to be positive because it was positive on every assignment, every problem assigned. But today we'll see one problem where that first number isn't positive, and we'll see what we're going to do about it then. But it's got to be in that standard form with a 0 on one side. That's done. So let's factor. This is going to be one of the things that's pretty easy to factor because there's not a number in front of the s squared. So we'll just put s and s. But let's stop and think about numbers that multiply together to give 10.
Tony, look at that projector over there.
Oh. Huh.
What happened to that projector over there? Oh. Tony, let's keep...
Okay, so I'll draw my two sets of parentheses. Do y'all remember doing this factoring last week? And this is one that's pretty easy to get started with because you just put S and S. Okay. Now, the second sign is minus. So what did we say about the factored form? What sort of numbers multiply together to give a negative 10? Well, one of these numbers would need to be positive and one negative. So we'll wait to fill that in. And since the second sign is negative, the outer and inner should subtract to give this middle term. With that in mind, do y'all think the 2 and 5 or the 1 and 10 are going to work? Yeah, the 1 and 10. So, how should I arrange the plus and minus if I want to get a negative 9? I still can't hear. I'm deaf up here. To get a negative 9, we have a 1s and a 10s. Plus 1 and minus 10, that's right, isn't it? We have a positive 1 minus 10. That would give us a negative 9s. So, to solve a quadratic equation by factoring, you make sure it's in standard form. Factor it. Oh, Tim, what are you doing? Oh. So now, once we have it factored correctly, we set each factor equal to 0 and isolate that variable. Well, heck, these are easy to isolate, aren't they? What do I do to get this s by itself? Yeah, move that 1 over. Theoretically, you're performing the opposite operation to both sides of the equation. Beginning with addition and subtraction, the opposite of subtracting 10 is adding 10. So, you want to type those answers in, negative 1 and 10.
Okay, and notice it asks you to separate them with the comma. There.
And if you're thinking, wait, it seems like we've done this before. Yeah, we did it on Wednesday. The first two problems are a review of what we were doing at the end of class on Wednesday. Oh, problem 2. Let me write that down. 3t squared minus t minus 14 equals 0. 3t squared minus t minus 14 equals 0. Well, is it in the standard form it needs to be in? Say yes. Numbers that multiply together to give 3. Ooh, this one's going to be a little bit harder because there's that number in front of the square term. Unlike this one where there was no number, so you just put s and s. So numbers that multiply together to give 3, 1 and 3. Numbers that multiply together to give 14, 1 times 14, 2 times 7. By the way, I'm going to make a statement about this set of parentheses right here, the s plus 1. When we said that there can be no common factors in the parentheses, that's other than 1. So when I said you can't have the two of the same number in the parentheses, I should have specifically stated other than 1, okay? This s plus 1 is fine, even though there's 2 1s in it, okay? The 1s and the 1, okay? As a general rule, no common factor other than 1. You can't have 2 even numbers in the same set of parentheses. You can't have 2 of the same number other than 1, okay? So that's why this s plus 1 is okay. Now back to this over here. I'll draw my 2 sets of parentheses. Oh gosh, second sign is minus. Numbers that multiply together to give a negative 14 would be a positive and a negative. For this 3t squared, how do we want to do that? Just t times 3t. I think I'll try the 2 and 7. Generally, I'll try the numbers that are closer together first, but I didn't up here on this one, just because it just seems so obvious. If you subtract them, you'll get the 9. That's why I went with the 1 and 10. But let's see, if I try the 2 and 7, if I try the 2 here and the 7 here, can I make this work out? When I look at the inner and the outer, the inner would be 6t, the outer is 7t. Can I subtract those to get that negative 1t? Yeah. So that would mean, follow my logic, let's see. The bigger number would have to be negative. So the negative should be on the 7, plus on the 6. So continuing to go backwards there, we should expect, or we need to put would it be a plus in front of the 2? And a minus in front of the 7? Did I factor that out correctly? Now, I'll set each one of these factors to 0. I'm running out of room. T plus 2 equals 0. Now, that one's pretty easy. Just move the 2 over. Can y'all see that? Am I too low? T equals negative 2. That's my first answer. And then I'll move over here to be able to lift it up a little, to do 3t minus 7 equals 0. How would I go about isolating that t? I would need to add the 7 and then divide. Okay? So add 7 to both sides, divide both sides by 3. We want the t completely by itself. That's probably dividing by 3. Sometimes I'll see students divide by 7. No, that wouldn't get the t by itself. In fact, that'd put a 3 over 7 in front of the t. So we have 2 answers. Negative 2 and positive 7 over 3. Negative 2 and 7 over 3. Okay, common punching back in. Negative 2, comma, 7 over 3. Any questions there? I'll take over. And when you get to this point, this is when you're going to do the next question. Problem 3 is already done for you. Move on along. I'll put this arrow up here to get next question. The second method that we'll be using to solve quadratic equations is the square root method. A square root method, I'm going to state it formally. It says that if you have something like x squared equaling a number, I'm using an n to represent a number, then x, the thing being squared, has to equal the positive or negative square root of that number. And I think you could convince yourself of that just by looking at an example.
A real basic example, like x squared equals 36. What numbers can you square to give yourself 36? I say what numbers because there's two of them. What can you square to give yourself 36? Give me one of those numbers. 6, okay, I agree.
I'm going to even say positive 6.
Positive 6. Give me another one. Negative 6. Okay. Positive 6 times positive 6 gives us 36. Negative 6 times negative 6 gives us 36. So, as long as the equation can be written in the form something squared equals a number, you can use the square root method. Now, do I have a pencil with an eraser here?
Oh, let me look. I'm sure I have it in here.
Oh, well, don't worry about it. Don't write this down what I'm about to do, okay? Well, I'll go ahead and write it. Suppose the equation would look like this. X squared equals 36x. In that event, you don't have the equation in the form something squared equals a number. You have an x variable on there. You cannot use the square root method. Okay? Cannot use square root method.
SRN is standard notation in all math books, foreign and domestic, for square root method. No, it isn't.
Okay, let's go on. Let's do one of the homework problems.
Oh, okay.
But as long as the equation's in the form something squared equals a number. If you have something being squared equals a number, you can use the square root method and realize for our purposes the equation will either look like just a variable being squared equaling a number, or maybe they'll have parentheses squared equals a number. And so look,
in either case, when you're doing the square root method, when you're going from here to here, the left side, I always write this out and I can tell Tim doesn't like it. You're dropping the square, and going from here to here, you drop the square, and on the right side, you take the positive and negative square root of that number.
What I normally say is you drop the square on the left, you pick up a plus minus square root on the right.
Oh, I like it worded like that. Okay, I didn't know that's what you normally say. Let's look at number 4.
Number 4. Okay. 3x squared equals 33. And let me switch over. Tony has a doctor's appointment in 2 weeks, and so I'll be here by myself. And you can rest assured this table is going down, and I'm going to be sitting down, okay? Oh, standing is better for your brain, you know? That's what they say. Your brain works better if you're standing. So, but I figure for that one day I'm going to sit down and I'm going to enjoy it. Well, when I look at this problem here, I see, oh good, I just have a number by itself over here, so hopefully I can use the square root method. But I have a question. What's being squared here on the left side? I guess the real question is this 3 being squared? No. If I wanted that 3 to be squared, it would have to be enclosed in parentheses. The 3 is not being squared, so I have to get rid of that 3. 3 times x squared. What could I do to get rid of that 3 in front of the x squared? Divide by 3, I agree. Once you do that, this falls out very quickly. You get x squared equals 11. So to use the square root method, you drop the square on the left, and what do you pick up on the right? Plus and a minus and the square root, okay. And this is really nice because
Is 11 a perfect square? Can we simplify the square root of 11? I think we're through with the problem. There it is, plus or minus square root of 11. Any questions on our logic here?
It's a little strange because you might think, well, wait, you didn't finish. There's nothing we can do with square root of 11. Unlike on 36, square root of 36 is 6. So we'll say, once you click here in the box, that's when it shows you the tools. Plus minus square root 11. Check the answer.
Any questions there? Let's do another one. Let's see. This is number 5. Let me write it down.
4x squared plus 20 equals 0. It's not in the form x squared equals a number, but I think we could write it like that.
Whenever projectors... I was going to make a colorful comment, but decided against it because it's being recorded. So here we go. What's being squared here? Just this x. That means the 20 can't be here, the 4 can't be here. We need x squared by itself. That's not too bad. What will I do first to get x squared by itself? I couldn't hear you. Move the 20 over. That's going to give us a 4x squared equals negative 20. Loud music at a young age. A father that thought that loud stereo equipment was an important part of any household. My hearing is, not that great. So when I say I can't hear you, I'm not saying I know teachers that do that because the answer's wrong or something. No. If I say I can't hear you, it's just that I can't hear you. Okay? And then what did you say to do to get rid of that 4? Okay, good. And that gives us x squared is equal to negative 5. Here's something that's interesting. When we were solving equations by factoring, did we pick up any imaginary numbers? Did we have any i's appearing? Well, that's when the square root is negative, but with factors, you don't have square roots appearing. When you're factoring, writing the 2 little sets of parentheses, you don't wind up with with square roots.
If you're solving by factoring, your answers are going to look like these here.
They're going to be rational numbers. They're not going to have square roots. They're not going to have i's.
Integers, or maybe some fractions. Like here we had a negative 2 and a fraction. But you're not going to have any square roots or i's in your answer. I think you've given away what
I did. I jumped to the punchline, didn't I? So here we are. We drop the square on the left. That gives us x equals. And what do I pick up on the right? Plus or minus and a little square root. And I have a negative 5. We have to think back to what we were doing on that second class meeting. First Wednesday, the Wednesday of the first week of the semester, we saw how to reduce square roots and negatives. I have a plus minus. Because that thing's negative, what are we going to have in our answer? Okay. We're going to have an I.
You can't do anything with.
I is a prime. 5 is a prime number. The square root of 5. There are no perfect square divisors. Just leave it. The square root of 5. And so with the square root method, this will give you imaginary solutions. Factoring doesn't do that. But
solving by factoring, you shouldn't have any i's or square roots in your answer. But with these methods, the square root method and the quadratic formula, you might get some i's or square roots in your answer. Okay?
So
never leave a negative under a square root. If you have a negative number under a square root, if you can't do anything else, replace it with an I out in front.
Let's type in the answer.
Plus, minus.
It was only about 5 years ago that Pearson introduced that plus minus hot button. It used to be we'd have to type in the answer. I square root of 5, comma, negative I square root of 5. I remember me and Tony badgering the Pearson rep back at the time, and the tech lady that handled the Pearson technology for Delmar, and I remember the day that we were up here and I saw this plus minus. Well, we weren't here, we were in the old building. I was teaching the class and I saw that little plus minus hot button. And I just had to leave the classroom and go next door to Tony's classroom. Have you seen it? He was like, yes, they put us a plus minus hot button. But imagine if every time you had to type, the positive, comma, the negative.
In later.
Yeah.
Okay. By the end of class, you'll know
it was a big deal to us.
Once we get to the quadratic formula, you might have some ugly answers. Number 6 is paying homage to the old Pearson, the way it's a multiple choice. Mm-hmm. But still, write it all down. And I was talking to him to write it down.
Mm-hmm. Yeah.
We'll do it as if it's not a multiple choice. Wait, no. There.
Well, this sure looks messier than the others, but remember I said that you can use the square root method as long as the equation's in the form something squared equals a number. It could be you can get either just a variable squared equals a number, or I said parentheses squared equal a number. And I think that's what we have here. We have the parentheses squared, a binomial being squared. Now, if we had a 36x, then just forget it. We couldn't use the square root method. But the fact that we have that number there by itself, we can use the square root method. And we know what to do with the square root method. We drop the square, so that's just going to be a 3x minus 5. But we pick up a plus or minus, and we're taking the square root of what number? 39. I have a question for you. Are we going to have an I in our answer? Are we going to pick up an I here? No, because the number under the square root is at negative. 39. Well, 36 is a perfect square, but 39 certainly isn't. Can we reduce the square root of 39? No. No perfect square factors.
Think of those perfect squares from day one. None of those divide into 39 because nothing divides into 39.
Other than 3 times 13.
Oh, you're right. 39's not prime. No. 3 times 13.
You're thinking 37.
I don't know what I'm thinking.
Well, here's what I'm going to do. I'm going to work with that plus minus as if it was just a single plus or a single minus. I want to get this x by itself. We got to get rid of the 3. We got to get rid of that 5. What will we do first to get that x by itself? Add a 5, I agree. So we have 3x equals, that'll become, I'm going to move it over, it becomes a positive 5 plus or minus the square root of 39. Now, we want to get rid of that 3. What are we going to do to get rid of that 3? 3 times x will divide by 3. So that cancels, and we have x equals 5 plus or minus the square root of 39 all over 3.
It's multiple choice.
Oh, it's multiple choice.
There's only 2 of them that have a plus minus key, symbol in it.
A, B, C, or D. With the multiple choice, if you have 4 options, I'll give you 2 chances to select the correct answer. If there's only 3 possible answers, You only have one chance to select the correct answer. So
without having to it's a similar problem.
Mm-hmm.
Like here, there's only 3 choices. A, B,
We
C.
better get it right on the first go because. Oh, wait a minute. Any questions on number 6? Going back to number 6. No? Okay, so now number 7.
Make that a little bigger.
Okay. We have the binomial z plus 6 being squared, and that equals negative 14. Let's switch over.
Oh, yeah.
Okay. I claim this is still in the form, even though it looks messy, it's in the form that we need to use the square root method. Here we have the parentheses squared equaling a number. So we're going to drop the square. That's going to be just a z plus 6. But we pick up the plus minus square root of negative 14.
Oh, wow. Can we simplify that square root?
What do y'all think's gonna? There's something that's gonna appear in my final answer. Read my mind. What am I thinking about? That I, that negative there in front of the square root.
And under the square root.
I mean the negative under the square root. I'm gonna need to bring out an I. What about the square root of 14? Can I simplify that? 7 times 2, but are either of those perfect squares?
I'm thinking there's nothing we can do for that square root of 14.
I'm thinking you're right, Tony.
4 doesn't divide evenly into it. 9 doesn't. The next perfect square is 16. So we'll leave a 14 in the answer. Or under the square root. But you haven't got the variable by itself. What do you have to do to get that z by itself, Tim?
Minus the 6, I agree. Okay, and you'll notice something, what I'm doing. The things, when I move this stuff over, I'm putting it in front of the plus minus. Okay, it's just standard form. The thing that doesn't have a radical goes in front of the plus minus. The thing you move over goes in front of it. So we have z equals, that's going to become a negative 6 plus minus I square root of 14.
And I can't imagine how this problem has survived as multiple choice all this time. Surely, somehow they missed it.
Yeah.
There's no reason why this couldn't be one where you just type your answer in.
No, just a 14. That negative, what took the place of that negative?
The I.
The I in front.
But this line here is not a negative on the 14. It's just your box here.
Yeah, that's just my box.
So let's see. Negative 6. Oh wait, I don't have to type it in. It's multiple choice. Let me make it. Yeah. Okay, so there's only 2 chances. I mean, 3 possible answers. You only get 1 guess on this. Which one is it? A, B, or C? It's certainly not C. It is.
It's not a guess, Tony. We know that it is option A.
In fact, that's the only one that even has an I in it.
Mm-hmm.
Right?
So as soon as we saw that negative 14 was going to pick up an I, we could have chosen A because it's the only one that had an I appearing. And
so this is all fine and dandy. Sometimes you can factor the stuff, like problem 2. But not all quadratic equations will factor. Okay. But other times, if you can get it written in that form, x squared equals a number, or parentheses squared equals a number, you can use the square root method. The natural question to ask is, what if it's not in that form? Like problem number 8, it says use the quadratic formula to solve this equation. What the heck is the quadratic formula? Tim, let me
I'll let you take over.
Oh, I was going to let you keep doing it.
Oh, you're going to let me? Okay.
Yeah.
Okay.
I'll do it.
No, I'm going to do it.
Oh, okay.
Solutions. I'm going to state the quadratic formula. Solutions of the quadratic equation ax squared plus bx plus c equals 0 are given by, I should say, well, I think that's fine the way I have it. Solutions are given by, and it's a fraction.
And what he's about to write is what people will think of the quadratic formula. If someone says, state the quadratic formula, this is what they want you to say.
Negative b plus or minus the square root of b squared minus 4ac and the denominator is 2 times a. So if you know the numbers a, b, and c, you know the number in front of x squared, you know the number in front of x, you know your constant term, and the equation set equal to 0, then you can plug those numbers in there and you'll find the solutions, even if it's not factorable.
It will always give you a solution. There's no, it always works. Now, so let's do a problem.
But also remember, I like that a value to be positive, because if it isn't 2 times a, that gives you a negative denominator, which is generally frowned upon, and you'd have to, reducing it, it becomes sort of a hassle to eliminate that negative denominator. So my advice to you, whether you're factoring or using the quadratic formula, make sure that a value is positive. It's easy to do. We'll see an example of that in a moment. Yeah. Now let's go to the problem we were going to do. Oh, we're doing number 8. Okay. I tell you.
I'll make it a little bigger.
Y squared minus 12y equals a negative 31. Let's switch over to the work.
Okay. Is it in the standard form we need it to be in?
I'll tell you right now it isn't. There's something we need to do. What is it? Move the 31 over.
You've got to have a 0, just like on the when we were solving these the last time with using factoring. You had to have a 0 on one side.
So that minus 31, when we move it over, it becomes
plus.
Okay. And now let's identify A, B, and C.
But you might notice, you might think, I've always had students ask, well, why can't I just factor it? Can I factor it instead?
If it's factorable, you factor it and you go right ahead and do that. Even if the instructions say use the quadratic formula, I'll tell you right now, it's not factorable.
The only numbers that multiply together to give 31 are 1 and 31.
There's no way you're going to get that negative 12y. But if something is factorable and you want to factor it, go right ahead and do it. Factoring is my preferred method, okay? But at the same time, I'll be honest, without bragging, I'm really good at factoring. I'm pretty good at it, okay? So I can look at that and tell that's not factorable. So I'm going to write my 2 sets of parentheses. That's
no, you're not going to write 2 sets of
what
parentheses.
What am I doing?
You're going to write A equal B.
You're talking about
C
factoring. You're driving me crazy, making me want to start drawing parentheses. There's no parentheses. Let's identify A, B, and C. A is?
It's The number in front
One.
of y squared, so it's a 1.
B is negative 12, I agree. C is 31. And so I'm going to draw my little fraction bar there. Now I'm going to I'm going to set a good example. I'm rewriting that formula.
That way you can lift the page up.
There, okay. So here. This first thing, negative b, that's just saying the opposite of b. B is a negative 12. What's the opposite of 12?
Negative 12.
I mean, pardon me. B is a negative 12. What's the opposite of negative 12? A positive 12. So this is just saying change the sign on B. The negative 12 became a positive. Now, some of this stuff we're going to do in our head. B squared. Well, regardless of whether B is positive or negative, when you square it, what sort of a number are you going to get?
Negative 12 times negative 12 is positive 144. We know that. So watch out on this calculator. On a calculator like this, look at this. If I went negative 12 squared, what do you think it's going to give me? Negative 144. The square applies only to what's beside it, the 12, not the negative. But we know negative times negative is positive. In order to make it give me the right answer, I should have put the negative 12 in parentheses. So if you're using your calculator to square a negative number, you make sure you put that number in parentheses. Now the negative is also being squared.
So the point I was trying to say was B squared is always going to be positive. It doesn't matter whether B is positive or negative. So what I do is I just think B squared is positive. What's 12 squared? 12 times 12 is 144.
And I always do the B squared either on a calculator or just in my head. But don't show too many steps. Don't start writing negative 12 squared. Just square it. So you have one fewer step there.
Minus 4 times A times C. A is 1. C is 31. And 2 times A, we can do that in our head. 2 times A. A is 1. 2 times 1 is 2.
See, so the B squared and the 2 times A, don't show steps for that. I have people, they make 1,000,000 steps out of something when there should only be 1,000. Okay, don't show too many steps.
Same thing's true for that negative B. Just go to B and change the sign. That gave me the positive 12. Now working underneath the square root. Let's punch that in. The stuff under the square root.
Under the square root, we have a 144 minus, or subtract, 4 times 1 times 31. Okay, so I'm just calculating what's under the square root. A 20.
Is 20 a perfect square?
Something we were doing there, 2 weeks ago. Simplifying things like square root of 20.
What's the largest perfect square that divides evenly into 20? There's a number here that divides unevenly.
4.
4, I agree. So for the square root of 20, you're thinking to yourself. You're thinking, that's the square root of 4 times the square root of 5.
Replace the square root of 4 with
2, and the square root of 5 just stays as is.
That's the stuff we were doing on day 1. That's the thing that makes math difficult to some people. It builds. It keeps going. We're doing today what we did on day 1. It's just a small part of the problem.
Okay, so now there are two methods of reducing this thing that we saw in previous homework assignments. You can either look at the three numbers outside of the radical, factor and cancel, or especially if there's an I. If there's an I in the answer, remember the way we'd have to split up? Well, I think I'm just going to split up. I think I'm going to split these things up there and there. So that would be a 12 over 2 plus or minus 2 square roots of 5 over 2. Y'all remember splitting up? This is going to work out really nicely. 12 divided by 2 is plus or minus. What can we cancel here? The 2 leaving us just that square root of 5. So there's the splitting up method. And if you're viewing an example, I guess we should probably show them the other method.
Another way I'd mentioned before, just look at the three numbers that aren't under the square root. What could I divide all three of these numbers by? 2. So that would put a 6 here, a 1 there, and a 1 in the bottom. So we still get the same answer. How you should do that, it really just depends on the problem itself. We saw with complex numbers that you had to separate it. If you have an I in your answer, you have to do it like this. Because otherwise it's going to count it wrong. It wants it in that form A plus BI. But if there's no I, how you do it, really, it's up to you. You can separate or just leave it as one fraction and divide like that. Either way, we get the same answer here. On some of the other ones, we'll get different answers.
But they're equivalent.
Yes,
Let's punch in
6 plus or minus the square root. Control. Make it smaller again.
Okay. So we have a 6 plus minus the square root of 5. Any questions? So if you have a quadratic equation and you can't factor it, you sit there trying to factor it and you can't get it factored, you can always solve it using the quadratic formula. The quadratic formula always works. Questions?
I just thought it was going to be the square of 5, not 6 plus minus 6.
No, it's let's see, switch back.
Oh, yeah.
The 12 is the whole thing. Switch back. The 12 divided by 2 gave me the 6. The 2 divided by 2 gave me 1 square root of 5. Remember, you cannot combine something that's not under a radical with something that is under a radical. You don't get an 11 or a 1.
See, what's next?
Oh, let's see what's the next. This is 9.
Yeah. Okay. Let me write that down. Number 9. 2x squared minus 9x equals 1? Yeah.
Yes.
Well, this isn't in the standard form that we need it in, is it? What am I going to have to do to get in that standard form? Yeah, move that 1 over. So subtract 1. That's going to make it a negative 1. So we have 2x squared minus 9x and minus 1 equals 0.
I'm going to write out the values for A, B, and C.
And rewrite the quadratic formula.
Oh, yeah. I always write out A, B, C, then write out the quadratic. A is 2. B is, don't forget the negative, it's negative 9. And C is negative 1. And I'll write down the quadratic formula. Negative B plus minus the square root of B squared minus 4AC all over 2 times A. Well, let's start plugging in this negative B.
The opposite of negative 9 is?
Negative 9 is,
Okay.
There. Then plus minus the square root of B squared. Let's see, negative 9 times negative 9 is 81. So I'll just write it 81 minus 4 times A times C. A is a 2. C is a negative 1. And then I do the 2 times A in my head. What am I going to put in the bottom? 2 times A, 2 times 2. Is it a 4?
Working under the radical, you have 81 minus 4 times 2 times, I think I may have warned you all of this already, but it's a good time to remind you again. We want a negative 1. Is this the symbol I use?
No, that's the subtraction.
That's the subtraction. That's what I used up here after the 81. For that negative 1, I used the little negative sign, 1 equals
89.
That's 81 plus 8. Negative times a negative became a positive, so we wind up with a radicand of 89.
So we look at the perfect squares, 81, 64, 49, 36. Do any of these divide into 89?
I think 89 is a prime number.
Yeah. There's nothing that divides into 89. 4 doesn't. We can't rewrite it like we did. There was something earlier. But, Oh, the square root of 20 we wrote as 4 times 5. We can't rewrite 89. So what do we have? We have a 9 plus minus the square root of 89 all over 4.
Look at the 3 numbers outside of the radical.
There aren't, well, this
what's
is a
that
1.
assumed number there? 1, 9, and 4. The only thing that would divide evenly into 1, 9, and 4 is 1. So there's nothing to divide by and cancel.
So we can
if we're going to leave it as a single fraction, we leave it like that. But realize if your answer has an I, they are going to make you split it up and cancel individually, okay? So if there's an I, and I mentioned this just because on the test, if there's an I in the answer, you're going to have to split it up, or my lab's going to count it wrong. Okay?
We saw that 2 weeks ago in the homework with complex numbers.
Right.
Well, no, week before last, not 2 weeks ago.
In the Tuesday, Thursday class, there was a person on the front row, and she said, well, what about if you split it up when there isn't an I? And my math lab accepts that. If you want to always just be safe, okay, then the thing to learn, the thing to remember is
split up everything. Well, here we're not going to be able to cancel anything, but if you typed in 9 over 4 plus or minus the square root of 89 all over 4. If you type that in, my math lab will accept it. It's never wrong to split up like that.
But you don't need to.
You don't have
if there's
to.
not an I in it.
The only time you must split up is when there's an I up there on top. Is that clear? And as you make it doing your the review for the test, you'll see that because there'll be if there's an I on top, they're going to want you to split it up. So that's one of those notes that I would make as I was doing the review. Remember, if there's an I on top, split up.
9 plus minus root 89 all over 4. Okay. Any questions? Let's see. How about 11? Oh wait, that was the one that's 12.
Number 11 is so similar.
Let's do 12. Okay. Number 11 is just so similar to the one we just did. Don't write this one down. This isn't the one we're doing. Okay.
I'm not writing it down.
12. Oh, it is very similar. So 12. We'll do 12 instead.
This is number 12.
Just the numbers up there in the blue rectangle right above it.
I don't even have my laser pointer. I can't reach up there. Okay. Let's switch over.
Is it in standard form to solve a quadratic equation?
No, it's not in standard form. I need it to be set equal to 0. Now, it doesn't matter if 0's on the left side or the right side, but I'm not going to try to get the 0 on the left side because if I pick this up and move that x squared over, instead of having a positive 1 in front of that x squared, what am I going to have? It becomes negative. Remember, you don't want the number in front of x squared to be negative. So what I'm going to do, I'm going to move these two terms over to the left. So I have that positive 1x squared, and I'm moving these two things over, there and there. That's going to become a here.
9.
Okay. And here? Correct. And I'll identify my A, B, and C values. A is equal to 1. Now B is equal to, be careful, negative 8. Remember to take that sign. C is equal to, okay, positive 32. And we're going to write down that formula. Sort of a wavy fraction bar, isn't it? Okay. Negative b, the opposite of negative 8 is positive 8. Okay. B squared, negative 8 times negative 8 is 64. And we have a minus 4 times A times C. A is a 1 and C is a 32.
And I'll jump in at this point and do the bottom. I can do that in my head. 2 times A, 2 times 1 is 2. Oh, and I turned off my clip down. I wonder how long it's been on.
You know what's happening?
No, it isn't on.
The batteries are running. Yeah, because they're getting
dead so fast.
It's because the stuff inside your bag is pressing the button, the thing, and turning it on.
Oh.
You got to be careful. I think we need to leave them standing up.
I'm going to just buy some extra batteries and bring them with me.
Okay, well,
Okay,
Tony, let's punch the Radicand into the calculator. 64.
64. And then a subtract. I'm using this key right here, the blue key. 4 times 1 times 32.
That's 64 minus 128, isn't it?
Which is a negative 64.
Oh, this is working out nicely. We have the square root of a negative 64. It's been a long time since we've seen this, a perfect square under the radical. What's the square root of 64? 8. But since it's negative, what am I going to have to stick on there? An I agree. Oh, there's an I on top of the fraction, so we're going to split up there. Oh, wait. There, we're going to split up. So we have 8 over 2 plus or minus 8i over 2 8 divided by 2 is 4 plus or minus here 4i. I agree. For my final answer.
4 plus or minus 4i. I rearranged the batteries in it and it started working. I think. Is it working?
Yes.
The microphone's working now? Oh, okay. So, let me punch that in. 4 plus or minus 4i. Let me move this calculator out of the way. 4 plus or minus 4i. Check it. Any questions? We always want that x squared term to be positive. That's why we did not move the x squared over to the right, because then it would have been a negative x squared.
Let's look at number 14. Let me write it down.
Negative 4x squared equals negative 13x plus 14.
This is not in standard form.
But this whole problem sort of reminds me of number 12, in that the x squared is over here on the left, and here we moved everything over to the left to get a 0 on the right. But over here,
I'm not going to get a 0 on the right side, because if I move these terms over, I'm going to be stuck with what in front of that x squared?
Negative.
So if the a value is negative, I'm going to get the 0 on the left side. Pick that negative 4x squared up, move it over, and that's going to become a positive 4x squared minus 13x plus 14.
I remember once a student just telling me, they just absolutely hate having the 0 on the left. And I then, she had it written on a sheet of paper, and I said, then fine. And I marked out her 0 over here, and over here wrote equals 0. There. That's all. Yeah, okay. Now it's the way you want it to be. It doesn't really matter if the zero's on the left or the right. What's important is to have that x squared term positive.
X squared term coefficient.
Coefficient, yes.
So A is equal to 4, I agree. B is equal to, and C is equal to, okay. And we rewrite that quadratic formula so we don't forget it. The opposite of B, the opposite of negative 13 is 13, I agree. It seems like every one of these examples has given us a negative B value. That's just a coincidence that B seems to be negative all the time. It can be positive or negative. Now, B squared, negative 13 times negative 13 is 169. I agree.
Perfectly fine.
Punch it into your calculator.
I just say 13 times 13.
You know
it's going to be
positive.
Negative 13 times negative 13, positive 169.
And then we have a minus 4 times A times C. A is 4. C is 14. And what's the denominator? We can do that in our head. 2 times A, 2 times 4 is 8. I agree. Working under that square root.
I'll punch in 169 minus 4 times 4 times 14. A negative 55.
A negative 55. Read my mind. What are we going to have in our final answer? Something's going to appear in it. An I agree. Is 55 a perfect square? No. Are there any perfect square factors that divide evenly into 55? 49, 36, 25, any that go in evenly? So we're going to be stuck with that 55, okay? But what are we going to do because of that negative there? Okay, we're going to bring out an I. We still have the square root of 55. And if you type that into my math lab, they're going to not take it. What do we have to do? We have to split it up because it's a complex number, a real number, plus or minus an imaginary number. They're going to make us split it up. There's not a lot of reduction at least, but they're still going to want us to split it up. 13 over 8 plus or minus I square roots of 55 over 8.
Nothing cancels.
For my final answer. Any questions there?
Oh, wait. Let me type it in. By the way, we did not have a break because there's only one more example to do, so
I always forget about the break.
I know, I just thought about it.
What time is it? Oh, okay.
It is 3:26. We have one more example after this, so...
I had a student from Tuesday, Thursday email me about number 13, and I haven't had a chance to reply. Maybe we'll have time to do 13 also, so I can see what was causing the problem.
Oh, well then, okay, there'll be more than one example to do.
Plus or minus? No, put in the plus or minus.
I square root of 55
all over 8. I should ask you, y'all have encountering problems entering answers? I got the hang of the toolbar and stuff. And now if you click in the little box and it doesn't give you the toolbar, that means there are no special symbols to type. You're just typing the answers like 7 or something. And
did you want to go ahead and do 13?
I thought we'd do 15.
Oh,
okay, and then go back.
It's going to seem sort of.
I'll do number 15. You did it the last time in the last class, didn't you?
Oh, okay.
15. Look at this. I'll let y'all look at it.
Oh, okay.
There. What do y'all think? It's in standard form. I'll tell you right now. AX squared plus BX plus C equals 0. It's in standard form.
But there's something. What makes it look bad? The fraction.
That's right.
There's no time with the quadratic formula that you should ever have to be using fractions for A, B, and C.
In previous math classes, you would have seen.
Oh.
Mm-hmm.
Oh.
Do you think that's too small the way I'm writing it?
Oh, no.
Can y'all read that? Do y'all think? Should I write it bigger? I think I will. Okay, I'm going to write it bigger. I'm going to use 2 lines. 1/3 x squared plus 1/15 x minus 1 is equal to 0. In previous math classes, you would have learned that you can multiply both sides of an equation by anything you want to except for 0. You can't decide, I'm going to multiply everything by 0, because you turn everything into 0 equals 0. You can't multiply both sides by 0, but you can multiply both sides by any other number you want to. Here's what I want to do. I want to multiply by a number that will cancel out these denominators. I need a number that'll cancel out 3, and a number that 3 divides evenly into, and a number that 15 divides evenly into. This is called the least common multiple. So 30 would do it. There's a smaller one, but 30, do you agree that? Let's see. Can I come over here? We had 1/3 and a 1/15. Don't write this down. You can multiply 3 by 30. Multiply by 30, multiply by 30, multiply by 30, and that would cancel the denominators. There's a smaller number, though. Not 3, because if you multiply by 3, here's a pencil. 15. There it is, okay? Now, the 30 is okay. You could use 30 at the end. When you get to the square root stuff, you'll just have more reduction. But we say that 15 is the least common multiple of 3 and 15. You're asking yourself, what's the smallest number that 3 divides evenly into and 15 divides evenly into? And y'all said 15. So I'm going to go through. I have to multiply both sides by 15. That means I'm distributing. I'm going to have to multiply every term by 15, even if it doesn't have a fraction. I'll have to multiply the 1 by the 15 and the 0 by the 15. So I'm multiplying by 15. That's like a 15 over 1. A 15 over 1. That's not a good color. Why am I using a pencil anyway? Let me use something real bold. I'll use this black pen. 15 over 1. 15 over 1 times 15 and times 15. Maybe I should have reviewed cross-canceling before we did this, because we're going to have to remember how to multiply these fractions. What I like to do is cross-cancel. I say 3 goes into 15. How many times? 5 times. 5 times 1 gives me a 5x squared. Plus Let's cancel the 15 over 1 times 1 over 15. 15 goes into 15 one time. 1 times 1, oh, this is nice. That gives me just a 1x. Minus, there are no fractions here. Nothing's going to cancel. 1 times 15, what's my new constant term? 15. 0 times 15 stays a 0.
I think this form looks... My battery died again, so I'm without the microphone. I think this looks a lot better than that. Oh, the original one. What did the original one look like?
Oh, I kept marking it out.
Theoretically, no reason why you couldn't use the quadratic formula. A equals a third, B equals 1 over 15, C equals -1. But for just a little bit of effort, multiply through by 15 and cross-cancel those denominators.
If you multiply by 30, you would have 10, 2, and 30. Still nice integers to work with.
Easier to work with than fractions.
Those fractions.
All right. So now write up your A, B, and C.
Well, any questions on what we did there? I would not use fractions for A, B, and C. I would ask myself, what number divides evenly into every denominator, and multiply through by that. Because now it becomes pretty similar to the others. A is equal to 5. B is equal to, not negative, well, just a 1. Finally, we have a B that's positive, and C equals -15. So, remembering our quadratic formula, -b plus minus the square root of b squared minus 4ac all over 2a -b, the opposite of 1 is... No, the opposite of +1 is, I could hear you. Well, I heard Tony say it, -1, okay. B squared. 1 times 1 is 1. And then minus 4 times A times C. So A is 5, C is a -15.
Let me pull up my calculator.
All 2 times 5, I agree with 10.
Okay, so I'm punching in under the calculator. Under the square root. 1 subtract 4 times 5 times negative, that's the little minus down here in the parentheses, 15.
That's a 4 minus 3 minus a -300. That's a 4 plus 300 gives us a square root of 301.
Oh wow. Can that be simplified? We'll look at our list of perfect squares. Well, I'll start with, I'm sure 144 doesn't divide into it. Neither does 121. Neither does 100. That's going to give a decimal. Is there a perfect square that divides evenly into...
I think 301 is a prime number. Are we going to be able to reduce the square root of 301? No. Are we going to have an I in our answer? Yes? Let me see. Wait, are we? No, because the 301 is positive. I didn't remember, okay? If I had an I, we'd have to split up. But if you can't reduce that,
36,
they'd let you punch this in.
All is one big thing.
All is one big fraction, and they would take it Remember that student I was telling you from Tuesday, Thursday? This was the point where, okay, it didn't matter. She was splitting it up that way. She'd always know if it was on a test, whether there was an I or not. She knew it was going to be counted correctly. And if you want to be safe like that, it's a hassle typing it in. Well, maybe it isn't. My Math Lab will take either one of these. My Math Lab will accept either one of those answers.
Now, I'm going to punch it in like that.
No, because I want to verify that. Watch us be wrong. Watch them change the program.
They couldn't have changed it over the weekend.
You don't think so?
Well, let's see. -1/10.
Get out of the denominator.
Plus minus fraction square root 301 over another 10. Yeah, but if this is one that you don't have to separate it. It would have taken it all as one fraction. Why? Because there's not an I in it.
Switch back.
Oh.
I'm not sure y'all understand why. With an I, they would not have taken it. If you typed that in as a single fraction on number 14, they would not have taken that. It had to be split up. On number 15, since there was no I, it didn't have to be split up. Okay, they would have taken either one of them. But the student of ours from the Tuesday, Thursday class, she was the one that pointed out that they'll take that split up form, and that's what she's doing from now on to make sure that she always enters the correct answer. Any questions there? And
that was every example I wanted to do, but Tim said he had a student that emailed about number 13.
Number 13. Weird time.
Okay, we'll do 13 and then call it.
It looks painless enough, doesn't it? So I'm wondering if it does.
There's no fractions in it.
There's no fractions. It's already. What do y'all think? Is it in standard form? Yes, it is. So when Tony and I looked at it, deciding which examples to do, we thought this one looked pretty painless, and so that's how it got. We didn't do it, but let's see. And you switch over.
Let's write out A, B, and C.
Okay, y'all tell me. A is equal to 1, good. B is 3, I agree. And C is -7. And we write out our quadratic formula. So now we're going to start substituting in. -b, the opposite of 3 is -3, I agree. B squared, 3 times 3 is 9, I agree. Minus 4 times A times C. A is a 1 and C is -7, all over 2 times A. 2 times 1 is, okay, we have a denominator of 2. So far there's nothing unusual about it.
Let me pull up my calculator and punch it in. 9, subtract, that's the blue minus, 4 times 1 times a negative, that's this symbol, 7, enter, 37.
Just a plain 37?
Yeah.
9 plus 28, I agree with 37.
Is square root of 37 going to simplify any?
Are we going to have an I in the answer? No.
My math lab would accept this answer right here. Or you could split it up. Do you have to split it up? No, because there's no I on top, so -3. But either one of these, either one of those would be acceptable.
I'm going to
punch in a single fraction. Just a single fraction's quicker, I think.
-3 plus minus square root of 37 all over 2. I don't know what.
I bet it was arithmetic here.
Yeah. Any questions on that?
We're moving on along.
Yeah, that's where we're going to stop here.
Yeah, they're just moving right through. That was what? Assignment number